Okay, so for this question here, the first bit of information, 16 cars a day, and we have 4-door cars and 2-door cars. So let's say F is 4-door cars. Now, if you don't have this already, that's fine. If you have something else, you have X or whatever, that's fine. And T is 2-door cars. So the first inequality is going to be F plus T is less than or equal to, not less than or greater than, less than or greater than, no, less than or equal to 16, okay? That's the first one. That one should be easy. The second one is a bit trickier, right? Second one's a bit trickier. So we have to have, they have to make at least twice as many 4-door cars as 2-door cars. At least twice as many. So this is similar to the last question we just did, right? So at least twice as many 4-door cars as 2-door cars. So if they were to be equal, if it was to be exactly twice as many 2-door cars, an equation would look like this. 2 times the one that they make fewer of, which would be 2-door cars, would be equal to 4. That's the 4-door cars, sorry. That's the minimum, F. So is this going to be greater than or less than, do you think?
Less than.
Okay, it's going to be less than, is it? So remember from last time? We're okay with the F being more than twice. So it's going to be 2t is less than F. Okay? So now go ahead and, again, the nature of this, we want whole number cars, right? So F is an element of whole numbers, and so is T. We can make 0 of them, I guess, if they want, but they can't make negatives, right? Okay. So I'll let you guys finish this here. Show me what the graph looks like, and then what combinations of 2 and 4-door cars can be made at the factory. And so show me your graph, pick out points that are in that feasible region to explain your answer. Okay, so the question was would it be 2F? Okay, so it says you have to make at least twice as many 4-door cars. So that means, let's say this is 4-door cars. We have this many 4-door cars. It has to be at least twice as many as the 2-door cars. So in order to make them equal, the equal part of this, you'd have to double T to get F. Does that make sense? But F can be more than twice, right? It has to be at least. So this would be a minimum over here. Okay? I know when you read that, because I hear what you're saying, at least twice as many 4-door cars. Well, that's 2 times F. No, it's actually 2 times T to get F. Okay, so if you're having trouble, just look up here. What do we want to make? Do we want to make T down here, or do we want to make T up here? Let's see. I did this once here. Let's see if I can figure out what I did here. Okay, so yeah, so let's make F here and T over here. Okay, 2-door cars on the bottom. And so if we want to make this as an equation, F equals 2t, or y equals 2x, we're going to have 0, 0 as a point, right? That's going to be the intercept. And then we're going to have a slope of 2. Okay, so again, with the graph paper, this is going to be a little bit, I'm just making a rough sketch here right now. This one over here is going to be, I'm going to manipulate this equation, it's going to be F equals negative t plus 16. So we're going to have 16 over here, and we're going to have 16 down here, and it's going to be a line connecting them. Oh, a little fuzzy there. Okay? Yeah, perfectly imperfect. And so again, check your equations to find the boundary lines. And of course, I won't be too sticky with the whole dotted thing. When you're drawing these, don't worry. I understand, that it's going to be dotted because we're talking about whole numbers. But when you're drawing your lines, I don't need you to just place the dots where the intersection of the grids are. Okay, just put a solid line is fine if it's equal to. Okay, just so you know that those values that are acceptable on there will be allowed. So if you did your solution region correct, you should have, I think, your arrows pointing down for this one, right? And then to the left or up for this one, correct? Okay. So we're talking about this solution region in here and a bunch of dots, right? This is where we're living. Okay. So the combinations should be in there. You could probably pick any combination that's in here that you want. For the company to make money, you probably want to make more cars than less. So you don't want to pick, maybe 1 and 3 or something. You want to pick something, either close to this end or close to this end probably, right? So something up in here for the company to make. Because they can make up to 16, so there's no sense making 3, right? Let's make something close to 16 or right on 16, right? So again, if you're thinking about it. What we're going to do now, though, is we're going to take a look at the graphing calculators. So I handed out graphing calculators to each of you, so you should have one on there. And this is what we're going to do. We're going to turn it on. And you're going to hit y equals. You see this y equals button right there? So on the TI-83, this is exactly what yours looks like. Hit the y equals. Okay. And then what we're going to do is we're going to plug in the equations of the lines. So remember, f was y, so that's good. So you just put 2, and then the x is the variable button. So 2, and it's going to show up as x there, okay? So this is going to be y equals 2x is going to represent f equals 2t. Let's graph that and see. Okay, there we go. So that looks kind of similar to this line right here, right? This one right here, this line.
Okay,
everybody got that or no?
Nope. Y equals 2x.
Okay, y equals 2x. Everybody got this here?
Yeah.
Okay, so for the next one, negative t plus 16, use this negative button. You cannot use the minus button. Negative and minus are totally different. So this is a negative t, or the negative x variable here, plus 16. And then if you graph that, you'll see another line. Now, the problem is if you have a standard window like me, you're not going to be able to see the feasible region fully. So let's change the window. Okay, here's your window button. Let's change your window. We don't need any negatives for x. So let's go, well, let's just do a 0, 1 so we can see the axis. So negative 1. Yeah, for x max. Let's go to, we have to go past 16. Sorry, for x min to negative 1. X max, we have to go past 16. So let's do maybe 20 there. Y minimum, we don't need any negatives. So let's just see the axis. Let's do negative 1. And then for a y max, we got to go over 16 again. So let's do 20 there as well. So if you have your window settings kind of like this, don't worry about the scale or the resolution or anything like that. Don't worry about that. Hit graph. And you should see something like that. Okay? That looks pretty close to what we manually drew there, doesn't it? All right. Now, here's the other cool thing the graphing calculators can do. If you want to see this, you know this is the feasible region. But watch what the calculator can do. If you go back to the y equals menu and you back cursor over so that the cursor is blinking on this, and you hit enter 2 times, it will shade the region above the line. And is that what we want? Yes, that's what we want. So you see that? See that function there? And then you go down and you hit enter 1, 2, 3 times, and it'll shade the region underneath this line, and then your graph will look like this.
What will they think of next?
Okay. Yes, this is the prelude to floating cars. Yes, you're right. This is craziness. All right, so there's your feasible region. Now, the only downer is you have to tell the calculator to shade above or below. It's not going to figure that one out for you. You still have to tell the calculator which side to shade. But once you got that figured out, there you go. That's kind of what your graph should look like. Can I do that again? Sure. Go to y equals, back cursor to this function right here. And you hit enter and you can do different things with it. You will have to use your graphing calculator for parts of the test, yeah. Okay. All right, so we have to answer the question here still yet. So it says, what combinations of 2- and 4-door cars can be made at the factory? Okay. All right, so let's see here. If you hit this trace button, the cursor will show up, and the trace will kind of slide along one of the lines. Now, it's not going to help you too much because these are all decimals, but at least you can kind of see, right? You can kind of see that the x, okay, if it's anywhere around 3, or 3, you know, let's see, let's go a little bit more. So this is close to 3, right? There we go, 3, then the y has to be greater than 6, right? So you could have 3 and 7. That would be in that feasible region there, right? If you go closer to this intersection point, it looks like 5 and 10 is pretty close. I don't know if I'm sure if 5 and 10 would work. Would 5 and 10 work for both of these inequalities? Let's see. 5 plus 10 is less than 16. Okay. 5 is our t, so 2 times 5 is less than or equal to 10. That's true. So 5 and 10 cars would work pretty good. Yeah. So 5 and 10 would be one of your best answers there, probably. Okay. Here's another thing you can do. Hit second function trace, and you can just hit, so you get to the calculate menu. This calculate menu is going to be very important for you in math going forward. Okay? Boys, are you paying attention here? Okay. I don't think anything we're doing should be too funny on the calculator. Is it? You got something funny on there that you're laughing at?
No.
Okay.
We're trying to fix it.
Oh, you're trying to fix it. Okay. Okay, so calculate. All right, calculate. Second function trace, that's the calculate menu. Hit enter, and you can plug in an x value. And it will show up, the y value will show up for one or both of the lines. So watch. If I did x equals 4, and I hit enter, look at this. 4 and 8 exactly are on this first line. That's the y equals 2x line. If you hit your cursor up, it automatically pops to the 4 value on the other line. So this is 4 and 12. Okay, so those are whole numbers. So for this question, you could actually use those numbers to answer. So once again, second function trace is the calculate menu. You could go value, and then plug in a value. So I did 4, let's do 5, and see what happens. 5 and 10. Okay, that's on this line, and so that would work. We already determined that would work. If we hit the up arrow there, 5 and 11. Ooh, 5 and 11, that might even be a better option because that maxes out the production for the day, and 11 is more than twice the two-door cars. See that? So 5 and 11, you might argue that 5 and 11 would be your best option. Make you the most money and get the most production. Okay? Any questions? One more thing I'm going to show you how to do is find the intersection point. Now, the intersection point may or may not be part of the solution set, but it's a good idea to know where this ends up. Okay? So, second function calculate. On the calculate menu, look at number 5 there. Number 5. Okay? So, second function calculate, number 5, or you can just scroll down there, it says intersect. Okay? Intersect. The calculator is going to ask you, is this the first curve? So, by curve they mean line, curve, whatever. Same thing. And so it shows up on the top of the screen, and you say enter, yes. Okay? And then the cursor will flip to the other line, and it'll show you what equation the cursor is on in here. Is this the second curve? So you're basically telling the calculator, I want to find the intersection point between the first curve and then the second curve. So you say yes, and then it'll say, would you like me to guess now? And by guess, it means find you the exact answer. Okay? And you say yes, and it'll say, here's the intersection point. Okay? So it's exactly, you should have this exactly on your calculator, 5.3 repeating for an x value and 10.6 repeating for a y value. That's the exact intersection point. Okay? So that's not a solution for this question, but that's how you find the exact intersection point, which is going to come in very handy as we move through this stuff. Okay?
Should we do the second function trace and then the number 5 and then
Yep.
enter?
So one more time, second function trace to the calculate menu. Number 5 is intersect. So if you want the calculator to find the intersection point, you hit number 5. And then it'll say first curve, you just hit enter, second curve, enter, guess, enter. So just enter 3 times if all you have is 2 lines on your screen. Now, it is important to have your intersection point on the screen. If the intersection point's not on the screen, I don't think it's going to be able to do it for you. Okay? So you can label that on your diagram if you want, 5.3 and 10.3. All right, any questions about that? That's a full example with everything in it, including how to do the graphing calculator. Okay?